Hi guys, this is Angela from the App Brewery. And before we get started digging in and building apps, the first thing I want to talk about is how exactly does an app work? Because we all have it in our phones. We use it to do really important things like banking and contacting friends. But there's actually very few people who knows just exactly how an app actually works. So let's start off by getting an overview of that. Now, the first thing we have to realize is that smartphones are actually no different from just any other computer. And an app is just code that we write to tell that mini computer what it should do. So let's say we have an app that just has a single button on it that says click me. When the user taps on the screen of that phone, then the sensors in the phone register that tap and sends a message to the operating system, which in the case of an iPhone would be iOS. Now, the operating system then looks at the data that it gets from the sensor, including things such as how much pressure was applied onto the phone, at which location on the phone screen did it register that pressure, and a whole bunch of different things and a whole lot of numbers. But the operating system takes all of those numbers and makes sense of it. And once it does, then it'll know that this particular button on the screen of this particular app was tapped at this time point. And then it'll send a message to the app in question telling it that, hey, this button of yours got tapped. What should it do? And so the code that you write for your app should specify in this situation, when the button called click me gets tapped, this is what it should do. It should change what's shown on screen, and it should do this and that and that. So essentially, as an app developer, you're planning out all of the scenarios and what should happen in each case. So it's almost a bit like emergency planning. If the building is on fire, what should happen? Well, we should probably evacuate the staff, and we should probably shut all the doors to prevent the fire from spreading. Well, it's exactly the same for apps. What should happen when a user taps on this particular button? Well, we should change the screen background to red, we should show them some other pieces of information, and then we'll wait to see what the user does next. And then there's a plan for how to respond to the next event. So there's essentially only 3 components to every single mobile app. There are the user interface elements that you see on screen. So that can be things such as buttons or images or toggles and sliders. And when we first build our app, we're going to set up the screen. So we're going to drag on some buttons, place it in a location that we think makes sense, and then add images or add other interface elements to the screen. Now, when those elements get interacted with by the user, say somebody taps on the button, then we've got the second component of the app that comes into play, which is the code. And this code is the plan. If this button called click me gets tapped on, then what's the next thing that should happen? Well, it's step 1, do this, step 2, do that, step 3, do that. But if the user, say, used the slider, then in our code, there'll be a section that plans for what should happen when the user uses the slider. And finally, most of the apps, especially if it gets more complex, will have data that's stored in the app. So for example, let's say we have a contact management app, right, where we have all the phone numbers of all of your friends and colleagues. Well, on the screen, when the user taps on a button that says, show me Bob's phone number, then that will send a message to our code, and we check through all of those lines of code to see how we should respond when the user taps on that button. And then the code will go into the data and fetch the relevant piece of data. So in this case, that's of course Bob's phone number. And then it's going to send it back onto the screen and display it on the screen so that the user now sees the telephone number of Bob. Now, previously I mentioned that a smartphone is just like a smaller computer, but there's still a few crucial differences. The first difference is that a laptop or a desktop computer is usually plugged into the wall, but a phone, on the other hand, is usually wireless. We usually keep it in our pocket and it's not always charging. It's also a lot smaller, so the battery gets depleted much faster compared to a laptop. Now, a phone also has less processing power. So if you try to play something that's really intensive on your phone, say the latest Far Cry, or if you try to run Photoshop on your phone, then it's not going to be able to do it because it has less memory and less processing power than your computer. So because the phone has limited resources on all of these fronts, then in order for a user to actually have a good time using their iPhone, then we have to manage those resources very frugally. So for example, you can't just make an app that drains the user's power in 5 minutes, or make an app that's so demanding on processing power that it's so slow and barely chugs along on the phone. So in all smartphones, there's always a manager, somebody to manage all of those resources. And that is, of course, the operating system. So it's iOS in our case that we need to worry about. And this manager is a little bit like the factory boss. It tells our app, hey, you're about to come on screen now, get ready. The user wants to see something from you, don't let me down. Or it might say, hey, you're draining the battery way too much, I'm gonna have to shut you down. Or hey you, little app, the user's getting a phone call right now. I'm gonna have to switch you off. Make sure you save their data before you go home. And this is what I think about every time I see my apps shuddering and shaking in fear. So previously, we looked at the 3 components that make up any app, namely the screen, the code, and the data. Well, we actually have to zoom out a little bit and see the bigger picture, which includes the role of the operating system. So when we think back to that plan that we're writing when we're coding up the apps, then that plan has to take into account all of the events that happen, not just when a button inside the app is tapped or when the user shakes the phone when our app is open, but also things such as when the operating system tells us that the user is getting a phone call. So our app is going to be switched into the background. So we have to also plan ahead for those situations. Well, if the user is getting a phone call, but they were midway through filling out a long form inside our app, we don't want them to come back after the call and realize all of that data has been lost. So we have to plan on how we save that data when a user gets a call, for example. So all in all, when we build an app, we're essentially writing a very long and very extensive plan to plan for what should happen under lots of possible scenarios. And when the app is launched on the phone, it looks to this plan to see what it should do. So in the course, we're going to be digging into every single aspect that we spoke about in this lesson. And this is a little bit of a teaser of what's yet to come and what you're going to be learning about, so that by the end of the course, you'll understand exactly how the app works and build any app that you dream of.